All right, welcome. In this video, we are taking a look at the a little mini lab with periodicity and looking at reactivity of various metals. And then our goal is to try and explain what we observe using periodic trends. So thinking about things like, how attracted are those valence electrons to the nucleus? So let's get this reaction going first, and then we'll talk about it. So we've got 3 different test tubes set up, and we're putting just some water in each of these test tubes. So we're going to have relatively equal amounts of water. And then we're going to put 3 different metals in each of the test tubes. We're going to test calcium, magnesium, and aluminum. And we're also going to take a look at what sodium does when it's in water, but that's going to be in a separate video because those reactions are a little more explosive. So that's not one that I'm going to be doing in here. So there's another video link with reactions involving sodium in water. So now I'm going along, I'm adding phenolphthalein, which is an acid-base indicator. And phenolphthalein, when it is acidic, it is clear. And if it turns basic, it will turn this hot pink color. In this reaction, we'll look at one of the products of this reaction is a base. So this will help us observe this reaction. So here's our metals. This one is aluminum. So I'm going to take a sample of aluminum and I'm going to put it over here in my test tube. And we can see it's not looking super exciting. We're going to let this sit here for a little bit. Now we're going to take our magnesium. This is what our magnesium sample looks like. We're going to put some of that in. There we go. And then we're going to put some calcium in here. There we go. Whoops. And we can see that one, something starts happening right away with our calcium. So there's a reaction happening that generates a gas. So this reaction goes, you will see bubbling. So if you can see that our calcium solution is bubbling pretty vigorously already. And in the process of this reaction, what happens is your neutral metals, your calcium, your magnesium, your aluminum, they are becoming ions. So in this reaction, your metal is losing a valence electron. So the metals that lose their valence electrons more easily are going to end up reacting a lot faster. And so you can see from this data right now, it seems like, calcium's reacting much more readily. So that tells us that it is losing its electrons more easily. And then you want to think about in terms of atomic structure, we want to compare calcium, magnesium, aluminum. Think about where those valence electrons are. So what shell are those valence electrons located in? What's the effective nuclear charge those electrons are experiencing? And that should help explain why calcium is the most reactive. I don't know how well this one shows up on video, but you might see that your aluminum is not really doing anything. But your magnesium is also bubbling. I don't know how well we can see the bubbling on video, but in person, you can definitely tell it's bubbling. It is not bubbling as vigorously as your calcium, but it is bubbling. So actually, I'm going to hit pause and we'll let this react for a few minutes, then I'll start recording again. All right, so our reaction has been going for a while, and the aluminum is still not really doing anything. There's no bubbles at all, but the magnesium is definitely bubbling away. And again, I don't know how well this is showing up on the camera, but it is definitely bubbling away, but not nearly as vigorously as our calcium, right? Our calcium looks like it's just really fizzing away and it turned that hot pink color. You can see some white stuff down at the bottom. That's calcium hydroxide. That's the base that's being created. So here we go. Clearly the most reactive, least reactive, then somewhere in the middle here. And then we want to think about, why this is in terms of the electron configuration and what's going on there. So, I sketched a little picture, for example, of your calcium. And there's different ways in which you can draw this out. But if you consider the shells and the number of protons, and oh, that's going to affect how attracted your electrons are to the nucleus. So like calcium has 2 valence electrons out here in the 4 shell. During this reaction, those metal atoms, what they're doing is they're losing electrons. So the atoms that lose their electrons more easily are going to be more reactive. You're going to notice them having a more dramatic reaction, reacting faster. And so if we think about our periodic trends and we want to explain behavior like this, we want to consider the location of the electrons and the effective charge they're feeling from the nucleus. So calcium's electrons are in the 4th shell. And then if we're trying to figure out their effective nuclear charge, well, you take the number of protons attracting them, which is 20, and then you subtract the number of core electrons that are repelling. So it's experiencing an effective charge of +2. And this by itself doesn't necessarily tell us a whole lot. What we want to do next then is compare this to the other elements. So compare calcium to magnesium and to aluminum, and then also to sodium. Because if you watch those videos on sodium, you'll see that sodium is a lot more reactive. So sodium loses its electrons more easily. Aluminum, it loses its electrons. It is least likely to lose electrons. So aluminum seems to have the tightest grip on its electrons. So you want to be able to explain why that is in terms of atomic structure. So that's our goal. And thanks for watching.